Welcome. Today we're going to talk about perimeter and area of parallelograms. Perimeter is the distance around a polygon. Remember, in Cornell-style notes, you write this in the right-hand column and come up with a question to which this is the answer. Perimeter is the distance around a polygon. To find the perimeter of any polygon, you add up the lengths of its sides. Since the opposite sides of a parallelogram are equal in length, you can find a formula for the perimeter of a parallelogram. So here we have a parallelogram with the length and width indicated. So to find the perimeter, we would add the lengths of the sides. So it would be W plus L plus W plus L. Well, since W and L are actually unknowns, we can combine our like terms here. Grouping W and W and L using the commutative property of addition, and then actually combining the like terms into 2 times the width plus 2 times the length. So this could be our formula if we needed a formula. You could always just add up all the sides. So find the perimeter of this figure. Remember, use the spacebar to pause the video, solve it, and then check your work. We're going to need the fact that opposite sides are equal. Then we can just add the 4 sides together. And 26 centimeters is the answer, right? If you get 26 what? 26 centimeters. Remember, perimeter is a straight line measure. It's a one-dimensional measurement of a two-dimensional object. So even though a rectangle has 2 dimensions, length and width, we're essentially just measuring a length that wraps around this rectangle. So find the perimeter. Again, pause the video, find the perimeter, and then check your work. Opposite sides being equal, we're going to have 10 plus 8 plus 10 plus 8 equals 36. 36 what? Inches. And one more perimeter for you to try. As any shape, we will add the lengths of the sides. So we have 6 and 4, 2 plus 3, plus 4, plus 7, plus 12, plus 8. The answer is 46 yards. Let's move on to area. Area of a figure is the number of square units that it encloses. So area is actually measured in squares. The squares can be different sizes, but whatever size squares you're measuring are consistent for the whole shape. So area can be calculated by multiplying the length of the base times the length of the height of the shape. Area equals base times height. In this case, it would be 4 times 2, so there are 8 squares. And in this case, we don't know how large the squares are, but it's 8 square units. Some examples of square units could be square inches, square centimeters, square feet, square yards, even square miles. Any size square is possible, and that would be called the unit. But before you find the area of a figure, you have to make sure that the dimensions are in the same unit. So here we have a figure where one side is measured in feet and the other side in inches. That is not going to work out. You can't have a square that's feet on one side and inches on the other. So you have to decide, do you want to measure in square feet or do you want to measure in square inches and then convert? It's probably easiest just to change 3 feet into inches. So ask yourself, how many inches are there in a foot? And multiply by 3. It's 12 times 3 equals 36 inches. So now we can use our area formula. The base is 36 and the height is 18. 36 times 18 equals 648 square inches. Notice that the inches to the second power is going to be read as square inches because that's indicating how many squares would fit inside the shape. That wasn't the only way to have solved this problem. We could have found the same problem by changing the inches into feet. Since there are 12 inches in a foot, we would divide 18 divided by 12. And we find that that's 1.5 feet, or 1.5 feet. So if we want to know how many square feet the green rectangle is, we can multiply 3 feet times 1.5 feet. So we find 4.5 square feet as our answer. And both of these answers are equally correct, the square inches answer or the square foot answer. As long as you're being consistent, either using inches or feet, you will do a great job. Now, on a parallelogram, the height is not this leg that's running diagonally here. It's actually something called the altitude. So here's our definition. An altitude is a line segment drawn from the side opposite the base and perpendicular to the base of the figure. Do you remember what perpendicular means? That's right, at a 90-degree angle. So here's an altitude coming down perpendicular to our base. And the length of that altitude we're going to find is the height. So let's write that down. The height, h, of a parallelogram is the length of the altitude. Therefore, the area of a parallelogram is base times height. It's the same formula we use for rectangles. Here's an example for you. Find the area of this parallelogram. All right, there's one piece of information here that we don't need. Do you know what it is? We don't need the length of the side because that's not the height. So each time we solve one of these area problems, we write the formula A equals B times H, and we plug in the length of the base is 12, and the length of the height is 10. So this will be area equals 12 times 10. Then we do the arithmetic. 12 times 10 is 120, and we put the appropriate label. In this case, it's square feet. The area of this parallelogram is 120 square feet. Here's another example for you to try. I'll check back with you in a moment. This one is interesting in that there's a side that we don't need, and there's a couple different types of units. So which side can we safely cross out? The 10 inches, that's the one we don't need. In this case, the base is 1 foot, and the height is 8 inches. So this parallelogram seems to be on its side. Do you notice that we have feet and inches? So I would just convert 1 foot equals 12 inches. And now we can write down the formula, which I've already done. Area equals base times height. And we'll plug in the base of 12 and the height of 8. 12 times 8 equals 96. And the unit is, again, square inches. Finally, we'll do an example of the composite figure. I call this composite because it's made up of smaller shapes. And when you get these composite figures, it's up to you to decide how to divide it up into shapes that you already know how to find the area of. In this case, we can divide this a couple different ways and get 3 rectangles. So I'm going to go ahead and divide it this way. And that makes the problem very simple, right? You figure out, of all these measurements, what's the base and what's the height of each rectangle. And in a couple cases, you have to figure out what the base and height are. They might not be labeled exactly, but if you know the length of the long side and you can see a shorter piece, then you can subtract because opposite sides are equal. So here I've broken this up. I'm going to go back just so you can try to figure it out for yourself how that worked out. So if this long side is 8, and I can see that this short side is labeled as 4, that means that this side also must be 4. And that appears to be the hardest part on that one. Okay, so now you can find the area of each individual rectangle. The orange one is going to be 6 times 4, the green one 3 times 4, and the yellow one 12 times 4. So we've got 24 square yards. 3 times 4 is 12 square yards, and 4 times 12 is 48 square yards. And we add those three together to get a grand total of 84 square yards for the composite figure.